Modern coding agents write thousands of lines of code in seconds. Give them a prompt, and a system expands outward, linking files and databases instantly. But unchecked speed creates a specific set of problems. Without strict boundaries, the agent builds features you didn't ask for. It weaves hidden structural errors deep into the logic. And before long, the developer loses the ability to read, review, or control the project. To harness that speed effectively, we have to change how we define the work. The solution is progressive slice-based development. A slice is a small, meaningful piece of a product. It represents a strict boundary, a single part of a feature that can be planned, built, tested, and reviewed entirely on its own. By forcing the agent to build only one targeted piece at a time, we maintain complete control over the scope and quality of the software. This architecture has 3 layers: database, API, and front-end. Developers often build horizontally, designing massive databases first. But without the upper layers, you can't test it. A vertical slice operates differently, cutting cleanly through all layers to extract a single, working end-to-end user flow. Let's apply this to a practical scenario, like planning a new task manager application. Building everything together, tasks, comments, sprint planning, makes the scope too large to manage. Instead, restrict the initial scope heavily. Slice 1 focuses entirely on 3 simple actions: creating a task, viewing the list, and updating status. This constraint ensures you deliver a functional, testable piece of the product that proves the core system works. Before generating code, explicitly define the edges of the work, what is included, and crucially, what is excluded. Next, establish strict acceptance criteria, deciding exactly how you will test the feature to know the slice functions correctly. Step 3 is mapping out the required layers. You identify exactly which parts of the database, API, and front-end need to be modified, and where this new code intersects. Finally, you preemptively identify the risks. You need to locate the dependencies that might break and isolate the specific areas where an AI agent is likely to misinterpret the instructions. These criteria serve as a rigid contract. They keep the AI anchored to a single objective and prevent the scope from expanding. If you provide an open-ended instruction, a coding agent will attempt to guess your future needs. It will naturally overbuild the architecture. A prompt asking an agent to build the complete task manager with sprint planning, comments, and permissions is a recipe for failure. It commands the AI to do everything at once. The agent rapidly assembles a massive, unstable architecture. Lacking a solid foundation of testing and review, the entire system inevitably collapses under its own weight. A highly controlled prompt gives the agent a precise, slice-sized task. It includes strict negative constraints, explicitly telling the AI, do not add assignment, comments, sprint planning, or AI features yet. This restriction forces the agent to return small, modular chunks of code. These chunks are easy for a human developer to read and verify. Effectively managing AI coding tools requires bottlenecking their output. You have to slow the generation down to match your actual capacity to review and understand the logic. Having the agent successfully generate the code is only the first step. It does not mean the feature is actually finished. Every single slice must pass a strict completion checklist before moving on. You must verify the main flow is functional and actively hunt for edge cases to ensure the code handles unexpected inputs gracefully. You must also document any known limitations. This protects the next developer and prevents your next AI prompt from compounding earlier mistakes. A slice only reaches the standard of done when it is thoroughly tested, documented, and structurally safe enough to support the next layer of complexity. When you finish a vertical slice, you secure a functional, deeply reliable core system that locks firmly into place. This creates a direct practical benefit. You have visible, working software early in the development cycle, which makes progress tangible and easier to measure. This methodical approach cuts down product risk. Because you are testing complete, end-to-end user flows, you catch structural and architectural errors in days, rather than discovering them months later. Once that specific slice is genuinely done, you review the learnings and start the planning process for the next adjacent slice. Real momentum in development relies on maintaining absolute clarity. Sustainable speed comes from moving forward with precision, knowing you never have to dismantle what you just built.